All right. Periodic table, a graphic organizer. One of the most important tools that you will ever use in chemistry is the periodic table. There's quite a bit of history with it. We're going to touch on a little bit, but we're just really going to talk about more about what it shows, what you can find, and we'll start with history, but the majority of it's going to be um, just how to read it, what it tells you, that sort of thing. It's certainly something you're going to find in any chemistry lab, any chemistry classroom. You walk in the room, first thing you'll notice is the periodic table. There's also different types you'll see, and you might even find it on the forearm of a crazy science teacher, like this picture here. Well, one man, Dmitri Mendeleev, is really considered the father of the periodic table. He was a Russian chemist, and he had an interest in the elements of the time, and he wrote the properties of these elements on playing cards. It's like a deck of cards. He liked to play cards, and he wrote the atomic mass of that element. He wrote its physical properties like density, um, whether it was metallic, whether it was a gas, that sort of thing. And he started to lay these cards out on a table. This is as the story goes. And he began to notice a pattern when he arranged them by increasing atomic masses that a periodicity started to occur. And he called this the periodic law, which basically meant that if you laid them out in a certain way, that elements that were in the same column had similar properties. Now, Moseley, a few years later, took Mendeleev's table and modified it somewhat. At the time, Mendeleev, they didn't know about atomic number. And there were a few things wrong with Mendeleev's table that he couldn't explain. But they didn't know about atomic number at the time. They only knew about atomic masses. The technology wasn't there. The science wasn't there to know the atomic number. So when Moseley attempted to adjust Mendeleev's table, one thing he changed was the arrangement. And he arranged them by increasing atomic number. And these tiny problems that existed in Mendeleev's table went away when you arranged it by increasing atomic number. There were a few other scientists, Lothar Meyer, who competed with Mendeleev, completely separate. They were not cohorts or anything. He published his work, though, after Mendeleev. And Mendeleev gets all the credit. They had similar results. But Mendeleev gets all the credit because he was first to publish. So that's a lesson to not procrastinate. This is a picture of what Mendeleev's table looked like originally. You notice there's a lot of scribbling out. There's list of elements, and there's their atomic mass. For example, here's oxygen, and we see that oxygen's atomic mass is 16. Carbon's is 12. There's a few that it's hard to read, but you get the idea. He was laying out just some ideas for coming up with his periodic table. Great picture here, by the way. And he took this and he modified it and modified it and modified it. And years later, it was put into a textbook, I think by Marie Curie, kind of updated. And it's basically this same look, just typed instead of written. And it's kind of tilted on its side. And that's kind of what it looks like. A few things that you'll notice. The groups are similar to what you would see in our periodic table. Not exactly the same, but similar. For example, group 1, column 1, hydrogen, lithium, sodium, potassium, rubidium, cesium. Those are in the modern periodic table in column 1. But there's also some that don't look like they fit. Copper, silver, gold. What's going on there? Well, this is what we mean by some minor problems with his table. He really didn't know where to put some of these, so he placed them where he thought they might fit. And later on in the modern periodic table, they found their niche. But he is really famous more for these areas here. These elements he placed into his table, but at the time, they didn't exist. So he predicted what they might look like, what their densities might be. He predicted that these elements would eventually be discovered and they would fit in these holes that he left. So he's really going out on a limb in the scientific community. And a few years later, scandium, germanium, gallium were discovered, and sure enough, they fit in these open slots. And that's what made him famous, was the fact that he used his idea of periodicity to predict elements that had not been discovered. So that's really put his name on the map. Well, Moseley came along a few years later, did it by atomic number, and many years pass, and we end up with what you're used to seeing, the current periodic table. This is the one that is in our textbook, which is copyrighted 2008. So this is an older version. There are a few changes that have been made down here. This has been named Copernicium. This one I believe is Fluorovium, and this one I believe is Livermorium. I might have them backwards though. This one is still pending, this one is still pending, and this one does have an actual Latin name for 117, but has not been officially named. First thing you might notice is there's a lot of metals on the table, a lot of metals. And these metals have a variety of properties. Some of them are very reactive, some of them are very inert. You also notice there's a lot of solids on here. The key up here with a little square is solid. So you'll see a whole lot of solids in the periodic table. And these are the building blocks of everything that makes up matter. Everything you touch is in some way, some combination of these items you see up on the periodic table. So we'll stop it here. This was part 1 of the periodic table PowerPoint. Part 2 will be coming